Welcome back to another episode of Hive School. Today we're going to look at creating custom models and UV unwrapping them. Today we'll be in 3D Studio Max, however I'm likely to make some more sort of add-on videos that will go along with this to cover making models and unwrapping them using Cinema 4D and Blender, and two other popular tools for generating 3D. So I guess we'll start with looking at just what's available to you if you don't want to do this process, and then look at how to do it and maybe a few of the reasons why you might want to create your own models. And this 3D process will be useful at whatever media server you choose. Most of them rely on sort of having 3D models in order to kind of function. But as usual, we're going to be doing this in Disguise today. So in Disguise is just a quick start project. We can create, let's just, I don't know, screen one. Create a screen. We can give it its resolution, which we might not know yet. So if you just want a flat screen, you can create one like that. Let's sort of move this up and out of the way of the initial surface that comes with us. And then if we want to scale it, these numbers are all in meters. It might be, I don't know, 4.5 meters by, let's say it's a 69 screen, so that'd be 4.5 divided by, that just gives us our 16:9 ratio. So generating flat screens is pretty easily done inside of Disguise, and there's a small set of meshes that kind of come inside the start project. So if you wanted a screen with a concave and maybe you want to, you can sort of modify the sort of size of that bevel, or set that back to 1. You can do things like sort of cylinders. So a cylinder probably wants to be like a bit more even in terms of the way that you scale it, but there's sort of models there for cylindrical screens, dome screens, spherical screens like puffer spheres, and then obviously that sort of default rectangle. So there's a few bits and pieces you can do sort of without having to disappear into any other software. And these work really quite well. There's almost all projects I think are going to have some of the default screens in them. The next thing that you can do, let's just get rid of some of these that you might not need to see. The next thing that you might want to have a look at is OBJ Gen by, I've written his name down so that hopefully I don't get it wrong, Marcus Bengston from the Disguise team. I hope I pronounced that right. So he's created this cool little web app where you can put in the parameters of the screen that you're using. So width, height, curvature, tile size if you want it to be divided into tiles. Gives you some information about what the screen will be. You can download it having put all that information in. Here's one I downloaded from there earlier when I was doing a bit of testing. So if we just grab that download, not delete it, but grab it. So I'm just going to copy that and put that into the mesh folder in our Disguise project. So we just paste that in there. And back in Disguise, one of our available screen types is now going to be the new 10x3 that we just downloaded from OBJGen. So that's another way of bringing in custom models, sort of UV wrapped and unwrapped and ready to go. If I apply a texture to this, you'll see there is a valid UV map. I probably need to set a 10x3 is, so if I said that was 1920, this would be 1920 divided by 20. So it's important that you set a resolution that is in the same ratio that the dimensions of your screen are, in order for content to render correctly. But ultimately, the model can be generated from OBJGen, and the UV map exists to allow you to create users. So I think if you're, particularly if you're doing kind of virtual production type stuff, Marcus's tool is pretty cool for that kind of thing. So let's say that the layout that you need isn't easily produced using these tools. Then you're gonna either the inbuilt disguise models, or by using OBJGen. I hope that's how you wanna. Hope that's how that's pronounced. The next thing you're going to want to do is think about creating your own 3D models and UV unwrapping them yourself. So as I mentioned, 3D Studio Max is basically the tool that I've been using to do this for a while. I know the Cinema 4D is probably still my 3D tool of choice, particularly for the way that it handles modeling and stuff like that. However, up until a fairly recent version, the Cinema 4D UV unwrapping tools were quite poor, so that's why I would often rely on 3D Studio Max, which has quite a robust set to do this job. In recent times, I think it was release 23 of Cinema. They enhanced all the UV tools, and like I say, I'll probably do another video that shows you how to do this process using Cinema 4D, as I think that would be quite useful, and a lot of people use that. But today's 3D Studio Max. So to remind myself and to help really hammer home the message here, I've just created a few quick Google slides to kind of prompt myself, and to hopefully make it quite clear for you guys watching this video exactly what the process is and what the pitfalls are. So if you don't, starting right at the basics, if you don't know what UV mapping or UV unwrapping is, this is, and here's a screenshot from 3ds that I've used to hopefully try and help demonstrate this point. UV unwrapping is the process of describing a 3D object using a 2D shape. Video, by its very nature, is inherently 2D. The content files that we create to put into our media servers are two-dimensional. They typically have a width and a height. If you imagine UV space like the width and the height of your content file, then really the question that we are trying to answer for the software that we use is, each of the faces of your model, where would you like us to take the information from the content in order to draw the overall texture correctly? So as you can see if we pop in, so these are the cubes, a set of cubes that I've made in 3D Studio Max to essentially demonstrate some of the pitfalls of UV mapping, things that you might want to try and avoid in order to get some quality and reliable UV maps. So that's what we're moving on to now, the key to good UV maps. The first thing that I would say when generating a UV map is what you want to do, if we open the UV editor for this, is make sure that each of these squares in here we would call a UV island, and each one of these UV islands represents a face on your 3D model. So the lesson here really is make your UV map occupy as much of the UV canvas as possible. So if I now draw the texture checker pattern here, you can see that we're really only occupying the tiniest corner of this, and we can see that that has been correctly drawn to the model. However, in order for you to just see these very small number of pixels, the media server needs to draw this entire canvas. So ultimately we're being quite wasteful, and if you were to have a lot of files or a lot of models that were generated like this, you would be making the graphics card in your machine calculate all these pixels here that ultimately were not getting shown on stage. So this is one thing to avoid. So fill your UV space as much as you sensibly can, and we'll get onto some reasons shortly why there might be some reasons why you can't completely cover your UV space, and we can have a look at that. The second thing that I would say is, unless you have a really good reason to, and I'll show you some good reasons why, don't overlap your UV islands. So if we move on to the next cube in the line, I think I just need to check off that. So let's open up the UV map here. So we're doing a little bit better than our first example. We're occupying a lot more of the UV map. In fact, in terms of the 6 faces that make up a cube, this probably isn't, you know, if it was laid out like 3 by 3, probably wouldn't be a bad overall UV map to do this. The problem is when you have UVs overlapping like this, it makes it quite difficult to create for your particular model, because the pixels drawn here are being shown on 2 parts of the cube at the same time. So let's say our director wants this side of the cube to be blue and this side of the cube to be green. Unless these 2 UV islands occupy unique UV space, the pixels that we draw here to be blue would also end up getting shown here. So it's quite important to allow you the flexibility to create content and draw content onto your stage in a flexible and easy to use way. I think keeping your UVs from overlapping is a pretty important thing to do. The next thing to think about is keep your UV islands in ratio. So if I take this, you can see the output. The output is always a square face. So your UV needs to be square as well. They always need to. So if we make this a square, it means the pixels that are being drawn are going to be square. Nothing's going to be stretched. It doesn't really matter how much of the UV space you want to take up. That depends on the rest of your model and what else you want to see on stage. But ultimately, it's really important that you maintain the same ratio between the shape of the face and the shape of your UV. Otherwise, like I say, as I showed before, things become very stretched, and there isn't really a good way. You're fighting yourself if you're generating UVs that have to be like later scale just to make things look right. So I think I've used the example. I've generated the example for this one, but then used the other cube to show you what you're doing here. The final one that I've drawn, I want to talk about even texel density. Ultimately, and let's get up the UV checker once again. When we talk about texel density, basically it is the relative resolution on each face of your 3D model. So I'm not really sure why the face is black. I think it's just a shading thing. Ultimately, you want the same number of pixels per meter, so the same resolution to be shown on each face of your model. So we've got 6 even faces within our cube. If we don't keep them all the same size within our UV, some of them are going to be really low resolution, so only show a very small number of pixels. Other bigger ones are going to be quite high resolution, so like this one here, we're going to see a whole load of pixels within that space. So if I just grab this and say like flatten mapping, there we go. So this kind of is an example of what I would say would be a good UV map, because we're occupying as much of the UV space as is kind of sensibly possible given the six equal sized UVs that we need to draw here. They are all equal sized, none of them are overlapping, and then in terms of their location, like within the UV, often people like to start at the top left, but it's just about trying to make your content creator's life as easy as possible. So now I've got these all the correct size and shape, I would start to think about which faces join together. So like those two join together. So in the UV, I'd probably want them so that content could flow from here over to here without the content creator having to think too hard or essentially move pixels around the map in order to kind of achieve that. So this is kind of where a map, so if I now do an unfold mapping, this is kind of where this UV is less ideal in some respects, because we have a lot more unused space. So if we see where the pixels that the faces are making up, the overall UV islands are smaller. So, however, each face, as I was talking about them sort of lining up next to each other, within the constraints of what's kind of, you know, relatively possible, the adjoining faces are all next to each other. So that's a pretty good way of doing things. And there are ways that this could be improved before we kind of get it into disguise. So something you may have noticed at this point is that UV space has been square. We call it normalized UV space. And I think this, and I could be wrong about this, comes from the fact that graphics cards love to render textures essentially in squares. So there's some efficiencies to doing this, but ultimately it's not the only way, and you can be quite wasteful if you insist on always working a square. So I'm sure a lot of the content templates that you will create for your content creators won't be squares, and there's a way to modify the way that our UV editor works in order to be able to kind of reflect that. So I'm just going to very quickly open up Photoshop. Oh, there's the title card for last week's video. So let's think. Let's say that each of these squares we want to be 540 by 540 pixels. So 40 times 3, 540 times 2. There we go. So we've generated a non-square pixel map. We can even go further while we're in Photoshop. If you hit the U key to generate a rectangle, we click there, and as we just said, we're going to make the resolution of these squares 540 by 540. So we've created our square. Black's not always the most useful colour. Make this red with a white outline. So yeah, click to generate that, and then on Windows it's Control J to duplicate a layer. So there we go. So there's our 3 tiles. I'm just going to select those 3, Control J. So we're almost in the reverse of UV map. Often you generate your UVs and export them in order to create your pixel map. However, what we've done here is we've gone into Photoshop and we've laid out how we think our UVs need to be in order to have the most efficient map. So I need to just quickly save this off in order to be able to use it. I'm going to export as PNG. Content template. There we go. So back in 3D Studio Max, instead of applying our texture check, I'm going to go pick texture. It's a bitmap texture that we want to use. Grab the content template that I just saved. So now what this has done is things are starting to look a bit stretched. Our squares are no longer square, but ultimately that's because when they were generated, UV space was square, and now in order for it to get bigger, everything essentially has stretched. However, now UV space is the correct ratio for the content template that we know we want to use. So I'm just going to not unfold, but select those and flatten map them. So now we get our squares. We can then come in and basically just line up our UVs on top of our map. So this is why I kind of often call this reverse UV mapping, because we've generated our template first and now we're aligning our UVs back onto it. So we'll just very quickly do this. go. So that's great. It doesn't seem like that's totally aligned. Okay, so there's a certain amount of tweaking that goes into kind of getting this all properly aligned. This toolbar that I use down here, by the way, Poly Unwrapper, I've been using this so long now, I find it hard to remember which tools are Poly Unwrapper tools and which tools come natively in 3D Studio Max. However, if you are using 3D Studio Max, I would definitely recommend you having a look at the Poly Unwrapper plugin. So it just makes some of the functions of UV Unwrapping a lot quicker and easier. So here we are. We've generated a valid UV map. Just make sure that, yeah, this is the correct one. So now if we export this, I'm just going to do it to my desktop again. So what I'm doing here is I'm exporting the. We don't want all those cubes. We just want the one that we've correctly UV mapped. So we just do export selected cube. I'm just going to leave that on my desktop. Make it easy for me to find it. And then we need to get into our D3 projects. UV Unwraps, the project that I've got open at the moment. Again, a bit like the model that we downloaded for OBJGen, we need to copy it into the mesh folder in order to be able to use the content that we generated, which is our pixel map. We need that in D3 project as well. So I'm going to copy that PNG, drop that into my video file. So back inside of Disguise, screen 1. Here we go. We need to re-add our LED screen. I'm just going to set the scale back to 1 again, and then just find our cube. Yes, we moved it over. So there's our cube. The position of it in the scene is relative to the position that we left it in 3D. So if we look like that, then that's essentially where it is, although not in the center of the scene, in the correct location as to where we did leave it. It's important that our model resolution is set to the same as our UV size, or essentially content template, because that's what we use to generate the UVs. So we can remind ourselves what that is. 1620 by 1080. So 1080 by 1080. That's great. And then we can grab our content template, and we can see that it's correctly being mapped. I mean, the fact that we've just left a white border around the side doesn't really teach us anything. So let's actually make this content template have some different colours so we can actually see what's going on. One more. Let's just make a grey one. Yeah, okay, that'll do. So I'm going to re-export this. Can use the Disguise versioning system, so Copy that and drop that into we're in the video file folder there. So now when we pop into Disguise has versioned that file up, and we can see that the texture is correctly fitting the 3D model that we made. So for projection work where you're not using LED, the really only way to create your models is to create your own 3D object and create a UV map for it. If you're doing sort of creative LED, so like a fractured screen or something, one might say, you know, what would be wrong with creating lots of different, so let's say these are narrow but tall, so let's make them 10 meters by a meter. So let's say you had these LED columns, and maybe you had a few of them. I don't know, maybe you had 10 of them or something like that. The reason to sort of create your own model instead of making multiple screens within D3 is down to optimization, really. Each one of these screens, although the number of pixels it occupies might not be huge, each one of these generates what's called a render target, which is a process that happens behind the scenes in Disguise that takes the content that that you program on your timeline and draws it to the screen. Ultimately, rather than having 3, 5, 10 of these targets for a set of fractured screens, a much better way of doing this would be to let's get rid of all that. Be to create them all as a single 3D object. So let's do the same thing. Let's make these 10 by 1. They're not quite in the right orientation, so I'm just going to 90 that, and then there you go, sit it on the deck, and then let's so that scenario that we were talking about, let's make a whole pile of these. So in order to keep things optimized, we want all of these fractured screens to be running as a single model, so single render target makes it easier for your Disguise system to play your file back, and allows you to do more interesting and creative things with your media, because you're not losing that processing power to doing relatively boring things like keep multiple screens kind of running simple pieces of content. So in this case, I've generated some random screens. Typically what you would want to do is you'd want to grab the specification of your screen and build it as per the LED that you're going to be using on site. In order to make these all part of the same model, they actually need in 3D to be all part of the same model. So I'm going to join them together. If I go, first of all, I'm going to convert it to an editable mesh, and then I can do an attach those all together. Now they're all the same model, we can apply UV map to that. So UV Unwrap UVW. We're going to open the editor. So this is back to what we were looking at before when we were looking at some of the different pros and cons of some UV techniques. I'm going to go down here and just give these a planar projection. So planar means flat, and in our case we want our UV projection to be flattened from the front. Why can't I select these? There we go. So projection, it's made it flat, but it's made it from the top, so we want to make that from the front. So now undo our projection. So now we have our models all laid out with the correct sort of gaps in between in our UV. We need to have a think about the size of this in order to work out the size of the template that we need to render for this. We could do, let's just assume that the height is 1080 pixels high, and then just grab a tape measure. Oh, 10.78. So show how bad my mental arithmetic is. So if we do 1080 high divided, not times by, 1080 divided by 10 meters. So that gives us the number of pixels that we have in a given meter, and then 10.78. That's the size in meters that the width of this is, times by 108. So that's the number that we got, pixels per meter. 1164. Dyslexia strikes. So 1164. So if we pop back into our, not in our tape, but our UV editor, and this is what I was talking about, the sort of forward method of UV. We're going to go, instead of generating our template and bringing it in here, this time we're going to generate our template from our UV editor. So 11, so it's 1164 by 1080. These numbers won't be completely arbitrary as I've just set them up. When you're working with LED, you can get these specifications from the manufacturer. So these are the correct size and sort of scale for what we've done with the numbers that we've just made up. So let's save this strips content template. Just need to tell this to be PNG. Okay. So again, we're going to export the model from 3D Studio Max. Put it on our desktop again. This is just going to be, I think I call it strips, sort of columns, whatever you. OBJ export. Strips. So that has to get copied like we did before into the disguise directory for our project. So open that up, objects, mesh, throw that in there. And then we need to put our content template in. So objects, video file, and then we'll just find the one that's on there that we just saved to the desk. We thought we just saved to the desktop. Here we go. So copy that in. So back to here. Instead of having our individual screens like this, let's make a combined screen. A strip screen, maybe move it out of the way of the original one. And we can add, caught the Windows key there. We can add a video file in order to draw our content template. So this content template, you see it's not drawing properly at the moment. We're not correctly seeing the content template on that model, and that's because the default pixel size for any screen in D3 is 256 by 256. So we just right click on the file, 1164 by 1080. We knew that because this is the size of the content template that we made, so 1164 by 1080. So when our content matches the resolution in disguise of our content template and the ratio that we generated in our 3D software, then everything draws correctly. And now you've got, well, 6 strips all being drawn with a single render target, and it's much more efficient than doing these all separately. So that's why you might want to create your own models. So I hope that's been useful. I might go through the process, like I said, of showing you UV unwrapping in Cinema 4D and Blender over the next couple of weeks. Hopefully this not only shows you the process of a couple of different ways to UV unwrap, the sort of forwards and backwards ways I think about this. The backwards way you generate your content template first and then align your UVs to, or the forwards way where we create our model and UVs and then we export that. And this could be brought into, if we wanted to make this a little bit more colourful, we could bring this into Photoshop and sort of fill that in, but I'm pretty sure you guys know how to do that. So thanks again for watching, and more very soon. Goodbye.